Today's vehicle is this 2013 Ford F150. It's got the 5.0 liter V8, and the customer brought it to me to inspect for a misfire. He wanted me to find out what's the cause of it and see what was going on. I scanned it. It's got a code for cylinder number 8 misfire. So before anything going forward, I am going to do a relative compression with intake pulse and ignition 1 trigger sync, just to get a good idea mechanically if we need to go any further than some mechanical issue. In order to get this to crank, no start, and keep ignition, just remove the fuel pump relay, and I will get you a sound of the cranking. And it does have a slight oddball cranking sound. Okay, so here is the capture off of that relative compression test that we just did. And even off in this far off view, you can actually tell that there are a couple anomalies. As far as the channel labeling, green is going to be the intake trace, blue is the amperage of the battery starter draw, and red is ignition coil number 1. Now if you look up here in the intake, we have this continuous repetitive anomaly, and then on the relative compression we do see a low cylinder. As far as identifying what cylinder is what, as far as the low cylinder, if we take a look at what our firing order is, so it's 15486372. If we apply that here from ignition 1 back to ignition 1 here, our firing order, so this is 15486372 back to 1. So our suspect or faulty low compression cylinder is number 8. Around that time also is where we see the anomaly on the intake trace. Now we've been on this vehicle as far as testing not even a half hour or so, just a few minutes of setting up and doing this quick test, and we right off the bat, based off of the misfires that they were complaining about, already know that there is a mechanical engine issue, and in reality there is no need to continue. We can accurately give the customer a good positive estimate as far as what it's going to take to repair this, and there really probably wouldn't be much more testing to do. As far as for me, I can try to just break down a little bit of the waveforms and maybe do a little bit more fine-tuned detail testing, but again, in reality, this vehicle is quickly diagnosed with a relative compression, and it helps to have the intake trace because you're 100% can accurately tell based on the two anomalies again that we have a mechanical issue. Based off of having the intake, I would say, and we can break it down in detail, but I would say that we are having intake valve issue on cylinder 8, and it's bleeding off into the intake manifold. Now to just break down a little bit more in detail on the intake waveform, that's going to help us give an even more fine-tuned assessment or diagnosis. If we look at the trace, we are going to look for intake pulls from each cylinder, and you want to see 8 even looking pulls. Obviously we've got a motion that doesn't keep it all the same levels or all near the same level. If we look here, we have a pull going down there, 2, 3, 4, 5, 6, 7, 8. So there are 8 actual pulls going on, but we have this rise in pressure. Now this blue is from the cylinder after number 8, which is cylinder 6, where on relative compression after the low cylinder, the next one, the amperage does go up a little bit because the starter draw is greater, because it has to work harder to turn over the crankshaft, because previously it didn't work hard because there was no compression. That's why you get a rise in amperage on there. So that one is the 6, which is after 8. So this is 8 coming up on top dead center. Because it was coming on top dead center, if it has a leaking intake valve, that is where this pressure rise comes. And how I can tell, or you can tell that it's due to also a pressure rise, is because it basically interrupts the pull of this cylinder here by cutting it short compared to the others. You see how it's short as the piston comes up. It overcomes the vacuum pull by introducing higher positive pressure, and so then the direction of the manifold pressure changes and goes up until the next cylinder decides to pull. Now if you look, this kind of goes, it doesn't level off straight flat, but it levels off more than the other cylinders, where after the pull on all the other ones, it'll kind of raise back up until it waits for the next one. And see, this one kind of stayed, I'll call it steady. Yeah, it travels down, but it's not raising up. And that is how you can see also, that's the rate of speed of the crankshaft that you're seeing, that how it's slowed down. And we know it's slowed down because that's the high amperage cylinder. So you're seeing a cutoff of intake pull due to positive pressure being introduced by compression, leak down, bleed off through the intake valve from cylinder 8. And then in the trace, you're watching the engine slow down in speed due to fighting compression and the higher amperage draw. Then you can see that here on the intake trace. As far as what this vehicle sounds like when it runs, we'll get you a shot of that. You can kind of tell it doesn't run terrible. It's not like a dead hole type of misfire. It's sort of a slight stumble. And so I'm letting it idle. Again, like I said, we know number 8 intake valve seems to be the issue. Okay, so I'm running the both cylinders number 1 and 8 to get a good look at what they are going to look on the waveform for a first cold start pressure in cylinder. Off camera, I actually ended up doing a couple more tests along with the in cylinder during running. I actually ended up doing some cranking tests. Again, this is just above and beyond. It's just for my curiosity, and so I wanted to show some of the things that I found on this. As far as this actual capture, this is cranking in cylinder number 1 with the intake trace. Now we know, and ignition for cylinder 1. Obviously we know cylinder 1 is a known good. It's not the one that's misfiring. So if we break this down into the 4 parts and concentrate down here on the bottom, you can see the in-cylinder cranking 4 strokes going on. So here is the expansion coming down, exhaust valve opens, it relieves, pressure changes, up to atmospheric. Here's the exhaust stroke. This column now is intake stroke. Pressure is going down into vacuum until this point. That is when the intake valve opened, because piston was traveling down. Only way for that to change is to relieve pressure, or relieve vacuum actually, by creating a leak by opening the intake valve. And so pressure then gets relieved, vacuum gets relieved, basically up near atmospheric, until we get into the compression stroke, which then the intake valve opens and pressure rises to create compression pressure. Again, there are the intake pulls. Here's the one that gets cut short. Here's another one, another one, another one, another one, another one. The pull for cylinder 1 is right here. And to show you, if you look down at the bottom where we know intake valve open, somewhere in that region is where the pull begins. As you see that intake trace traveling down. And the point where it stabilizes in the blue is the point where it's reached its point here on the intake trace, and it starts to go back up from being kind of stagnant until the next event, the next pull. So that's the relation within the in-cylinder and the pressures changing there compared to the relation and pressure changes in the intake manifold. If we take that and lock it like we did and look at the pulls for the other ones, as you can see there, the start of the downward pull until where it stabilizes is about the same. Again, for this one, it's about the same. Even for this one, even though it looks different, it's in time, it's the same. We know that one's that because it's our base. And here, again, about the same. Again, about the same. And lastly, about the same. Back to the one that I purposely skipped. You can see this is where I was talking about how it gets cut short. How this is that same in time distance, I guess, compared to this one where almost halfway it gets cut off and then pressure starts to go up. Anytime I see that where in time the pulls get cut short, it's due to introduction of positive pressure in the intake manifold, and you're only going to get that through a leaking intake valve most of the time from a cylinder on compression pressure, or also on exhaust. It's possible to happen on exhaust stroke, where I've seen that actually happen on a running engine. But nonetheless, that is the relation between all the pulls compared to the pressure in the in-cylinder, and taking note of what is occurring there just before the high rise. Now this capture here is cranking in cylinder for number 8. Now right away you can see down at the bottom there's a big difference from cylinder 1. Because we know we are leaking, our tower does lean, has a shorter side here on the right side, and then it goes into deeper vacuum because we've lost volume. That is why that is so deep. If we look here at the bottom side, you can see that the pressure in the intake manifold when cylinder 8 was on compression still took a little bit of time for it to fully, completely, I guess, engulf into the intake manifold in order for it to start changing the direction of pressure going on in the intake manifold. And what I mean by that is we know the intake valve closed here due to pistons already traveling upward pressure changes in an upward direction at that point, which means intake valves had to close, and now the piston then continues to go up. Now I'm going to concentrate and mark off some points here in this region of compression from cylinder 8, just to see what relation is there during the faulted situation. I'll get my 0 point, basically atmosphere. So that is that line there. We will now look and see where the intake level was at. So 0.6 below. So just over 1 inch of vacuum. That is where the closing event occurred. And then now we'll go up on the intake manifold, where we know the pressure started to change direction, which is at that point. And the difference between the two is just over 1 psi. And then in time, if we mark off where the valve closed to where the pressure started changing, it's this square here basically. So that's pressure. Intake valves closed, pressure started to go up. It started in vacuum and it crossed the 0 point and into positive. And at this point, as far as pressure in the cylinder, we are now only about a half psi positive in the cylinder. And at that point is where it started bleeding off into the manifold enough to slightly start changing the direction of vacuum into positive pressure. In time, it was 72 degrees. But even then, so what we're seeing is the amount of time it took, which was 72 degrees, and the amount of pressures to make it start changing directions. It went up about just over a whole psi, but from 0 upward, as far as positive levels, it was about, I guess, half a psi is what it's looking like. But again, we do know that that's what created cutoff of the pull in time and the change of direction compared to the others. And also we know that that is the lower compression cylinder. That is where we're seeing what we're seeing. And lastly, I wanted to just show you the end cylinders for both cylinder 1 and 8. First start and idle. The blue is going to be cylinder 1. The yellow is going to be cylinder 8. I also have the intake and the ignition, but those are kind of irrelevant during this capture idling. I didn't find anything conclusive there, oddly enough. So I will get those out of the way just to make things easier to see. If you look at both cylinders, they look pretty much similar. Even their levels of pressure seem to be pretty close. They're running at about 60 psi. Their 0 point are pretty much close as well. And even the vacuum points down at the bottom are pretty much even. Again, this is first startup, cold idle, which is a little bit on the high end to get things warmed up. To get you an idea, here's the mark. So it's right as it's starting up, and the idle is up high. So not much difference between the two then. The more we keep going, it's still a little bit high idle at this point. I even rev it up a little, and then after the rev up, it starts to then begin to stabilize and drop a little bit in the RPM. Did a quick rev up there, and again it starts to attempt to stabilize as it warms up. This is still high idle just before I give it some throttle. Both are still looking the same. This is during the throttle, and both about the same. I didn't peg it down to the floor, but so it just, I touched it a little bit. They both were up about 70 psi, and towards the bottom still looked the same. So we'll get over to this point where they start to defer a little bit. Now clearly the only thing we can tell is that there is lower running compression pressure between the two, about 3 psi difference between the two. Everything else on the bottom end looks and is pretty much the same. And we'll go over to the end point there. I did rev it up pretty high. Let's see. So I maxed out over 100 psi. But they both kind of similarly revved up, and pressure reacted pretty much close to the same on both. And again, lastly, towards the end, just before shutting it off, everything towards the bottom looks the same again. Only difference still true is the top compression pressure that one can build compared to the other. So again, about 4 psi there difference, and levels between the two for the atmospheric point for exhaust, they're about the same. The vacuum levels are about the same there, and nothing too crazy as far as identifiable towards this bottom section. And on the top, only difference is after it warmed up and stabilized by dropping the RPM to its normal idle point. The only way we can tell that there is a mechanical difference is by comparing a known good with the faulted one. Now, if you were to have gone directly straight into in-cylinder running compression pressure and done this test on cylinder number 8, the capture from compression, it doesn't look like too much of a faulted waveform. The towers don't even appear to lean as bad, because I mean, again, we're only losing about 4 psi here at idle during running, and there might be some sort of a lean, but not enough that where you can visually see it. Even down on the expansion pocket just before exhaust valve open, the difference is not even the level between the intake area from the expansion pocket. It's not offset, and it reaches about the same level. And again, if you didn't have cylinder 1 to compare it to, you almost wouldn't be able to tell or know that there was a mechanical issue. The way that we can is by comparing a known good and letting the idle stabilize. The key factor for finding differences, or between the 3 tests I just showed you, between relative compression, cranking in cylinder, and running in cylinder, the dead giveaway it was the easiest one, which was relative compression, which on all Misfire cars, that's the test that I always do. Even on cars that don't misfire, if I suspect some sort of issue or anything, I always do relative compression. Again, this car was diagnosed in the first 5 minutes. The rest was just for detailed information and my own curiosity and trying to learn more as I go. And what I ended up finding is that cranking in-cylinder waveforms give and tell more of a story for sure, 100%, and give you all the detail of what's truly 100% going on compared to running in cylinder. This only tells us that there is a difference in peak compression pressure pressure when idling. And again, the intake pulse waveform give us the final dagger of what's mechanically going on by aiding with the relative compression low cylinder number 8. It shows us that the pressure loss for 8 is bleeding off into the intake manifold, and that is our issue. So again, a little bit over informed on this one, past the basic test. Yeah, it's just for learning, so I wanted to just share this with you guys for those that are curious like I am. But this customer will be advised of what's needed, and that's heavy mechanical work. I'm not sure if he'll go forward with it, but at least I know for myself to not go chasing a rabbit and trying to sell stuff that isn't going to help what's going on. That's the main thing I always try to show and the work that I try to do. So I hope you guys enjoyed it. Thank you for watching and following along. Hopefully you understood what I tried to explain. So that's it for now. Until the next one comes along, I'll see you guys then.